Welcome back, welcome back, welcome back. I'm Lisa Blackburn. This is my YouTube channel where we talk about everything I want to, math and science related. Today we are doing notes and example problems for stoichiometry. Big fancy word for how much in math. All right, in chemistry, the math of chemistry. All right, so look in your notes. We were talking about this, April Fool's Day. Oops, you need skis. You're welcome. All right, so let's look at our next problem. Go look in your notes, number 2. And what do we do first when we have these problems? What should we do first?
Annotate.
We should annotate. And this is for every problem, any word problem from now on in math or science. So do this in physics. This is like, they don't tell you to do this in college physics, but if you'll just do this when you get to college physics, it's easy. You just figure out your knowns and unknowns, which formula you need, you plug it in, you get the answer. So we gotta do that. Okay, so what we're looking for are chemicals. So methyl salicylate, that's fun to say, is our first chemical. Is also known, that should be known, not know, as oil of wintergreen. Is made from a reaction between methanol, there's another chemical, and salicylic acid. That's fun to say. Salicylic acid is like the base material for aspirin. She gave me my keys here. All right. How many grams, so that's our question word, put a question mark on that. How many grams of salicylic acid are needed to produce 325 grams of methyl salicylate? So any number, make sure you circle that, and I'm going to put a little M by that because it's a mass with plenty of methanol. Plenty of methanol means the amount of methanol is not important. It'll say excess or plenty of, and that means not important. We don't care about that. Okay, that's step 1. What's step 2? Balance. We're going to check and see if the equation is balanced. 1 carbon, 7 carbons is 8, 8 carbons. 4 hydrogens plus 6 is 10, 8 plus 2 is 10. 1 plus 3 is 4, 3 plus 1 is 4. So I'm going to put a little check mark because it was already balanced. Okay, what's next? Write what you know. So we go up here and we find this number, 325 grams, and then we figure out which of these chemicals it is, methyl salicylate. We go back up here and we see it C8H8O3. We look here until we find C8H8O3 and we write underneath it 325 grams. Okay, and now we go find our question word. How many grams of salicylic acid? Salicylic acid is C7H6O3. We go find it, it's right there, so we put question mark grams underneath. Okay, what's next? Tell me what to do next. Not yet. We're going to look at the periodic table, and what are we going to find? The molar mass, and what's our symbol for that? An M&M, right. So we're going to draw a little M&M right here to remind us to do the molar mass. And we're going to look on the periodic table, and we have to get the molar mass for the knowns and unknowns. Nothing else. We don't care about them. We only care about what they gave us and what they're wanting. Okay? So we're going to start over here with this one, and we're going to write vertically C, H, and O, and we're going to write how many we have. 7, 6, and 3. Then we're going to multiply it times its molar mass. And the molar mass of carbon is 12, hydrogen is 1, and oxygen is 16. So help me out. What's 7 times 12?
84.
84. What is 6 times 1?
6.
Very good. And what is 3 times 16?
48.
Okay. All right? Okay, so now we add them up, and what is it? I'll look on my paper. I got 138.13 because I did the 13. So it should just be 138. Is that what y'all?
Yeah.
Okay, so now we write that underneath here. on our M&M line, 138 grams per mole. Always write your grams per mole. It's going to help you not get lost in the middle of the problem. Now we need to do it for this side over here. CHO. 8, 8, 3. 12, 1, 16. Okay, what's 8 times 12? 96. 8 times 1? 8. That's the easy one. 3 times 16? We already did it. 48. Add them up. And I got 152. 152.16. But we'll just say 152. All right. Now we're going to go over here and write it underneath. 152 grams per mole. Now what do we do next? We have to write down the mole ratio. So we look at the numbers, the coefficients from the balanced chemical equation, and here is 1 to 1. So here it doesn't matter, but it will. And when it does, if you don't do it methodically, then you will guess and you'll get it wrong. I mean, it's like it defies odds, because odds should say that half the time you should guess it and get it right. But it just seems like every time a student guesses it on this stage, they get it wrong. So it's weird. All right, now what do we do? The U, we'll make it pretty. All right, and we start from what you know. Oh, I didn't make it pretty. You start from what you know and go around to what you don't know and put an arrowhead on it. And notice before we went that way, now we're going this way. You can go either way. So don't let that confuse you, and don't skip drawing the U. That's going to help you. Because if you go from what you know to what you don't know through all of these numbers, you'll get the right answer. So now we're ready to do our problem. What do we write first? What we know, which is 325 grams. And this, what we are starting with is methyl salicylate. And what we're getting is salicylic acid. So we're going to call this grams of M, and we're going to call this grams of S. Okay, because this one is methyl salicylate, and that one's salicylic acid. So we're going to start with grams of M, 325 grams of M. What goes on the bottom? Grams of M. Whatever you have here, you write there because you want to cross them out. Grams of M. And then as we go around, what are those grams of M? 152. And then what do we write on the other side of the fraction bar? The moles. Does everybody see where that came from? What number goes with this mole? 1. It's an understood 1. Now, so these are moles of M. Now, what goes down here? Moles of M, because they got to cancel out. And that's this one right here. That 1 stands for moles of M. So on the other side of the fraction bar are moles of S, and it's that one, the next one that your U comes to. Now as we go on around, what goes down here? Moles of S. Gotta be. Because we want to mark them out. We gotta keep doing this until we've got what we want. So that is this mole right here. What number goes with that mole? Understood 1. What goes on the other side of the fraction bar? 138 grams. That's the fraction bar right there. So it's 138 grams. Grams of S. Now, grams of M mark out, moles of M mark out, moles of S mark out, and we're left with what we were supposed to have, grams of S. Multiply any number on top, divide any number on bottom, and do it on your calculator. Don't just watch me do it. Make sure you know how to do it, and see if you can get the answer. I got 295 grams of salicylic acid. Put a box around it. Make sure you practice this yourself. It's a whole different skill to watch me do it and go, oh yeah, that makes sense. And then for you to do it on the test. This test will not be Scantron. This is going to be a paper pencil test where you're going to be doing math problems through the whole thing. Okay, so this one is the math test. And you need to have your calculator and practice your math. There won't be many questions on it. It'll only be about 10 questions long. And they're all math. Okay? Because these problems are kind of long. I can't give you 100 of these. You'd never finish in time. All right. So let me know when you're ready to move on to the next one, to number 3. Do you feel like you understand these pretty good? I'm going to give you a worksheet to practice them for homework, and you can do it over the break. And on it, I have the answers given to you on the worksheet too. And you can do one, check your answers. Do one, check your answers. Make sure you're good at it. All right, can I scroll up? Anybody say no? Okay, I'm scrolling then. Ooh, I found the button the very first time. How many moles of water? Okay, so here's our next one, problem number 3. So ours is a little bit different this time. How many, so first what are we going to do? Annotate. So how many is my question word? I'm going to put a question right there, and it's moles of water. Are produced, here's a number, 1,400 moles of hydrazine rocket fuel. That's why we have a little rocket drawn in your notes. And then we're going to do it again because they also want to know how many grams is it. So first we're going to do the mole to mole problem, and then we'll do the gram problem. Okay, what's the next step? Balance. Is it balanced? Okay, let's look and see. 2 nitrogens plus 2 nitrogens is 4 nitrogens, and over here we only have 2.
No, it's not.
So it's not balanced. We got to work on it. Here we have 4 hydrogens, here we have 2. So it looks like we need to put a 2 here, but let's look at our oxygens. We have 4 here and 1 there. We have even and odd, so that makes it a little odd. So let's start with our oxygens this time. So if I have 4 oxygens here, what do I need over here?
4.
A 4. Okay, now let's look at our hydrogens. I have 4 times 2, which is 8. So what do I need over here? A 2. Okay, and now let's look at our nitrogens. We have 2 times 2 is 4, plus 2 is 6. So what do I need here?
3.
A 3. Now it's balanced. Okay, what's the next step? Write what you know. And what I know is how many moles of water. So I'm going to do a question mark mole. And then I have 14,000 grams of this. Grams of H, and we'll call this moles of water. Yeah, so this is a little different, isn't it?
Wait, why don't we put
No, it says moles.
Oh, we had moles. I was messed up. I was thinking about that we're going to do grams, but it's moles. So now we got to go back to green. We'll write mole right there. Very good. All right. Now, what's the next line usually? Periodic table, molar mass. Well, we don't have to do it because we already have moles. And so if you don't have grams, you don't have to do the periodic table. So we're going to do for our next line, what is the next line that we normally do? The mole ratio. And what do we have over here?
2.
And over here? No.
4.
A 4. So this is where our coefficients come in. It's 2 to 4.
Oh, okay. You don't
Now-
use the 3 because it's irrelevant.
It doesn't matter.
Okay.
That one doesn't matter either. All we care about is what we know and what we don't know. Okay, now what do we draw? A U. We'll make it pretty. We start from what we know and we go around to what we don't know. Now what do we do? Now we're ready to do our problem, right?
Can you try the ratio to 1 to 2?
We're not going to bother with that because that's an extra step and it doesn't matter.
Oh.
Okay, so we're whatever this is, we're going to just go with it.
Just don't simplify.
Don't simplify. Don't bother with that. Just use what you got. Don't even think about that. We don't need any extra steps, and it won't make any difference because we're putting it all in our calculator anyway. Now, if we were old school, before my time, before calculators, maybe we'd bother to do that to make the math easier. But we've got calculators, so we're going to act like it. All right, so now what do? Write what we're not write what we know. And that's our 1,400 moles of H. So we have two parts of this problem, part A and B. So this is part A. 1,400 moles of H. What goes on the bottom down here?
Moles of H.
Moles of H. What goes on top? Moles of. Okay, look at our circle. We went from moles of H to here.
Oh, 2.
So we're going to put a 2 here, and what goes here? A 4, and this is moles of water. What are we trying to get? So we're done. This is all we have to do.
Oh, it's just 4 moles.
So what's the answer going to be? We can do this one in our head.
What? Oh.
Multiplying the number on top, dividing the on bottom, it's 28,000. Oops, I freaked it out by going too fast. Try it again. All right, it's more fun with sound effects. You can put a little doop in there, it's more fun. All right, how do we feel about part A? I have found students find the easy ones like this harder if they don't really understand how to think through it. They start trying to throw molar mass in there when it doesn't belong. You've got to think about your steps. Think about what you're doing. Think about these units. It's the key. All right, now we have a B part of this problem. We'll make it blue. Okay, so B, now they want to know how many grams of this are produced. So this time it's how many grams.
So we just have to convert it?
If you have grams, no. Well, we're going to go back and show you just how to do the problem from the beginning. If you have grams, here we're eating our graham cracker. Where do we need to look? Periodic table. So we're going to have to get the molar mass. So we're going to have to go back and add molar mass here for the water. So H and O, I have 2 H's, 1 O. H's weigh 1, oxygen's weigh 16. 2 times 1 is 2, 1 times 16 is 16. I add them up, and it's 18.
So you don't include the 4?
No. Very important point that people mess up. The 4 is here, nowhere else. You do not include the 4, and if we were doing the hydrazine, we would not include the 2.
Never include your coefficient.
Never include your coefficients.
I'm fighting you with the
On the molar mass, on the M&M line, you don't include the coefficients. The coefficients go there. Okay? All right, so now we're going to do it again. And this time, we're going to end up with grams. I guess we need to go all the way over there. Okay, so what are we going to start with? What we know. 14,000 moles of hydrogen, of hydrazine. What goes on the bottom down here? Moles of hydrazine. So it's 2 moles of hydrogen, 4 moles of water. What goes on the bottom down here? Moles of water. And that is this mole right here. So what's the coefficient that goes with that, or the number that goes with that mole?
18?
Nope. One. It's an understood one. 1 mole of water. What goes on the other side of the fraction bar?
18 grams.
18 grams of water. Multiply any number on top.
Okay.
Divide any number on bottom. Moles of hydrazine mark out. Moles of water mark out. And I'm left with grams of water. Do it on your calculator. What did you get?
504,000.
Yep. And that's grams of water. Okay, how are we feeling about that one?
I'm watching it, so can you just, like, not if we're supposed, like, it's not supposed to, but, like, scientifically, can you just convert the 28,000 into grams?
You can. The problem is, it is best at this stage, because we're doing one problem with lots of variations, it's best if you stick to doing it this way. Because there's going to be more variations than this one. So now we've done grams to grams, we've done moles to moles, and we've done moles to grams. Okay, so let's do another variation. If y'all are ready. We'll scroll on and do another one. Find the mass of sugar. Sugar. Okay, find the mass of sugar. So that is, we're looking for a mass, and that's our question word. Required to produce 3 liters of carbon dioxide gas at STP. What's STP? Remember we learned that very first chapter. What was STP? Besides Stone Temple Pilots or an oil treatment? See, y'all are so young, y'all don't even know who the Stone Temple Pilots are. Great band from the 90s. No, y'all don't remember STP? Its science meaning? It's standard temperature and pressure. And what that means is we don't have to worry about temperature and pressure. We just pretend we just do the math. Don't worry about any outside variables, just do the math. So it's not really important. It's just telling you, do the math, don't worry about anything else. So, but we have to know the volume of 1 mole at STP. Do you remember that little fact we learned a long time ago? Nobody remembers that from our first chapter? It's 22.4 liters per mole. Do you remember that number now? 22.4? We mentioned it probably the first week, so it's been a while. But that's okay, you can learn it now. So what this means is no matter what gas it is, if it's at standard temperature and pressure, it takes up 22.4 liters. That's its volume, no matter what the gas is. It doesn't matter if it's a big molecule or a little, gas doesn't make any difference, it takes up 22.4 liters. And that's why we have our little balloon over there, to remind you of volume. All right, so let's figure this out. Which of these is sugar? It's this one, right?
Yep.
So we have question mark. If it's a mass, what are we looking for? Grams of sugar, okay? And now, then we are producing carbon dioxide gas. We're producing 3 liters of carbon dioxide. We'll call it just 3 liters of C.
Miss Blackburn, we didn't check to see if it was balanced.
Oh, we didn't check to see if it's balanced. We need to do that next. Is it balanced? Yes, because I gave it to you. See the 2 right there and the 2? So yes, check. You should always check and make sure I do it right though. Okay, now, we have grams, so what do we need next?
Periodic table.
The periodic table. So draw your little M&M to remind you that this is the next one. And we need to look up the mass, the molar mass of this. Good thing it keeps being C's, H's, and O's. It sure makes it easier, right? So carbon, I have 6 of them. Hydrogen, I have 12. Oxygen, I have 6. Now we're going to multiply. And carbon is 12. Hydrogen is 1. Oxygen is 32. 6 times 12.
30, wait, oxygen.
Oh, I did it wrong. 16. I'm already there. Look, I made it right. Okay. What's 6 times 12? 72.
Yeah.
Started with a 0. 12, 24, 36, 48, 60, 72, 84. Yep, you're right. 72. Okay, this one's 12. And now 6 times 16, 96. Now add them up. Let's see if I already did that. I got 180. So I'm going to write right here. 180 grams per mole. Okay, now with this liters thing, I don't need grams. What I need is this, that there is 22.4 liters per mole. So if it's liters, that's what you write down on this level.
Like at every equation?
Every equation. If it's liters of a gas, that's what goes there. Okay, now what do I write?
You multiply
Your ratio.
My mole ratio, which is
1 to 1.
1 to 2. Do you see that 2? 1 to 2. Now what do I draw? I draw my U, and I start with what I know and draw it around to what I don't know. Okay, and now we're ready to do the problem. Right? What do we write first? What we know, and it's right here. We're starting on this side, and that really confuses kids too. That you can start on either side. You can start on either side. It doesn't matter. That's why we draw our U, to keep you straight there. Okay, what goes on the bottom down here? Liters of carbon. Liters of carbon. Do you see it right here? So what is it? 22.4 liters of carbon dioxide. What goes on the other side of the fraction bar?
1 mole.
1 mole. Ooh, y'all are getting it. Yay, 1 mole of carbon dioxide. What goes down here?
Mole.
A mole of carbon dioxide, and it's 2. What goes on top? 1 mole of sugar. Because now we're on the sugar side. We've gone around our revolving door, and now we've gone from carbon dioxide to sugar. Now what goes down here?
1 mole of sugar.
Right, it's this mole right here. So it's 1 mole of sugar.
And then you put
And grams?
Now we put grams,
180.
180 grams.
So 180 grams per mole? Or grams
No, that your mole's right there. It is 180 grams per mole. That's the mole.
80 grams sugar.
Oh, you put
And it's sugar.
okay.
All right, so liters of carbon dioxide mark out, moles of carbon dioxide mark out, moles of sugar cross out, and we're left with grams of sugar. Multiply any number on top, divide any number on bottom, and see if you get the right answer. Which is, oh, I made a big old mess. I'll put it up here.
12.
Which is 12. 12 grams of sugar. Ta-da! Are we starting to understand it? This is considered the hardest part of chemistry.
Really? It seems
This is
pretty
it.
easy.
Yay! That's awesome. I'm glad you think it's pretty easy. If you don't understand it, don't feel like, I must not be smart. Nope, this is considered the hardest part of chemistry. But I promise you, I can get you to understand it. I haven't found anybody yet I can't get to understand it. You're not going to be the first. So you might need some extra help, come in, but did I scroll too fast? Okay, let's try our 5th example problem. How many molecules, so this time we're going to do molecules of hydrogen are produced by 6 grams of water. So this time we're going from grams to molecules, okay? So if you have molecules, particles, atoms, we need another special number. Which one do you think it is? He's Italian, he's fabulous. Avogadro's number, right? So,
2 times 10 to the 27th power.
very good. So if you have particles, molecules, atoms, you're going to need Avogadro's number. which is 6.02. Sometimes in college they make you do 6.022. But we'll just do 6.02 times 10 to the 23rd power. And it's whatever it is, it's things per mole. Sometimes that will be atoms per mole. Sometimes it'll be molecules per mole. Sometimes it will be particles. But it's whatever that is per mole as the unit you do. Now, do you understand how there's more than one version of this problem and why I want you to always just do it the way you do it? Because practice, repetition is going to help you do better. So that's why we want to just have this repetition. Do it so many times that on the test you're like, oh, I know what to do. Okay, so now what are we going to do?
Check to see if it's balanced.
Is it balanced? 2 hydrogens, 2 hydrogens, 1 hydrogen, 1 oxygen, 2 oxygens. What do I need over here?
A 2.
I need a 2. And what do I need there?
2.
A 2. Now it's balanced. What's next?
Periodic table.
Yes, because, well, no, actually, before we do that, what we know, which is 6 grams of water. So we put 6 grams, we'll say W for water. Okay, and what we don't know, which is we're doing hydrogen. So that's our question mark, and it's molecules. Now, what do we put on the next line? Periodic table. So draw a little M for M&M to remind you. And what is the molar mass of water? You might have memorized this one by now.
18.
It's 18. 18 grams per mole. Now, on this line, if it's molecules, atoms, particles, we're going to write Avogadro's number. This is just like the 22.4 if it's liters, but we're going to write Avogadro's numbers. And then this time it's going to be molecules per mole, because that's what they're asking for. We put the word molecules per mole. Now, what goes on the next line?
The ratio.
The mole ratio, which is 2 to 2. And will 2 to 2 cancel itself out? Yes, but I'm going to grade your work. And if I don't see that little 2 to 2, even if you got the right answer, I'm taking off a point. Because you didn't put your Buddy the Elf revolving door correct mole ratio. All right, so you got to get it all. Your work is going to be worth as much as your answer. Okay, so if you can just set up all the problems, you can get a 50. I know it's an F, but it's an F plus. And put it in your calculator and you'd have the right answer. Okay, what do we do next? You make our U, so we'll make it pretty again. We start with what we know, put a dot there, draw your arrow around to what you don't know. We'll change the color of the ink here. And now, we're ready to do the math. What do we write first? What we know, which is 6 grams of water. What goes in the denominator? Grams of water. And what number is going to go with this grams? 18. What number goes on the other side? 1 mole of water, and it's this mole right there. Because we go around the U. Are you starting to see the value of the U?
Yes.
It tells you what to do next. Okay, what goes down here? Moles of water. And what number goes with that mole of water? 2. What goes on top? 2 moles of hydrogen. And I'll just write H2. Okay, going on around my circle, and looking here, what goes down here? Moles of hydrogen. It's that mole's right there. What number goes with that mole? 1. What goes on the other side of the fraction bar? 6.02 times 10 to the 23rd molecules of hydrogen. Multiplying number on top, dividing number on bottom. See if you can get the right answer. You can try it on your calculator. It should be 2 times 10 to the 23rd molecules. Hydrogen. Put a box around it. You have to put a box around your final answer because I've taught for decades. We're not going to talk about how many. And I've had kids try to cheat by doing problems every way. So they'll go, look, there's the answer. Yeah, but you did it 10 other ways. You have to decide on your final answer. Now you have to pay for the sins of your predecessors. All right, any questions about that one? Y'all are doing fabulous. I tell you, this is considered the hardest part of chemistry. And y'all are just rocking and rolling through it. Okay, let's do another one. If you have 152.5, that's the number, grams of CO2 and 24.5 grams of H2 to make methanol, what is your limiting reactant? How much methanol could you make in grams? So there is our question word. Now this is a little confusing because we have not one but two knowns. Let me explain it to you and it will make perfect sense. Okay, say that I decide that I'm taking brownies to a party. So I'm at the grocery store and I buy 5 boxes of my favorite Ghirardelli double chocolate brownie mix. It's the best, way better than all the rest. No arguments. Okay, I got my brownie mix. I go home to make them and I get them all out and I've paid my water bill, so there's plenty of water in the tap. I've got a big thing of oil, good on that one, but I go to the refrigerator and I've only got 4 eggs. The brownie mixes take 2 eggs per mix. How many mixes can I make? 2. Forget the other 3, I'm only taking 2 pans of brownies to the party. Unless I can find like a vegan recipe that has an egg substitute or something, which I think you can actually use applesauce for. But I don't have any applesauce, so I'm only down to 2. So I had a limiting reactant. The limiting reactant was eggs. Does that make sense? In chemistry, we have that too sometimes. So I've got this much of one chemical and that much of the other one, but for one of those 2, I've got enough, and the other one, I don't have enough. The one that's really going to happen is the one that's less. The one that you only make, I only make 2 brownie mixes. I don't make 5. Does that make sense to you? That's why we have a brownie mix there and some eggs for our little picture. So if you'll just remember, think of brownies, and the other thing you have to do is you have to do it twice. So think of brownies. I like brownies. They are delicious, especially Ghirardelli. All right, and I like them really crispy. I like the corner pieces best.
Yeah, but they have to be like gooey on the inside, so you can get
Yes.
a contrast of.
It's kind of hard to bake. Like I do homemade stuff, so.
Yeah.